Projective capacitive touch panel is an array of electrodes that have intersections. At those intersections, they form capacitive nodes that made from various materials, laid down on various substrates. The user interacts with those capacitive nodes, and the result is touch information being forwarded to a control device where it is then processed into whatever a gesture or a touch or whatever reaction you were looking for at the time. Projective capacitive, you have fast touch response, there's low latency, you have high signal strength to noise immunity, self-calibrating, there's a lot of features. Works in a variety of applications, bare fingers, gloves, stylus. Medical application. You have industrial control and instrumentation. There's, again, a lot of these you've seen already. Point of sale. Gaming is big. We have auto and aircraft infotainment. Marine navigation. You have outdoor applications. You have security and control. Engineering test equipment. You have building automation, kiosks, information exchange, media entertainment, education, workplace collaboration. Challenges that we've had recently over the last 5 years, particularly with the glass ITO solutions that we have, low manufacturing yields. You have it's complex panel design, everything from printing on differing materials, how the material is actually taken off the glass. Those all introduce manufacturing challenges. If you're looking for accuracy, if you're looking for in a multi-touch application how touch adjacency gets when you draw that line and you see it crossing back and forth, that's when the panel no longer can sense the two fingers. It appears as one. So touch adjacency is huge. Scaling from small to large makes those electrodes get further apart. So you have to have more electrodes. You have to have more node counts to address that. Harmonics, noise, etc. Noise filtering becomes very critical as you design the panel, and not just the panel, but as we work with you to design the panel into your application. It's important from my perspective that I understand how to design panels, how to implement features in a industrial design that satisfies your hunger for bezel-less or smooth look, cleanability. We also have to remember that a projective capacitive touch panel is not a 2D device. It is actually a 3D device, a three-dimensional device, both electrically and physically. Our panel has thickness, and the thickness varies based upon the application, based upon sensitivity, based upon lens cover material, based upon the end application. Gloved application, stylus application. We have to design the panel in a Z-axis to make sure that it works in that environment. You also have to understand that we're projecting a field off that panel. It may not be a very tall field, but nevertheless, electrically we're designing a 3D field that has to be accounted for in your design. So EMI, the effects of susceptibility, all of that has to be taken into account, and it's a partnership between the panel designer and the industrial design, electrical design team. Overcoming the challenges of scalability here, we have to add more nodes, which basically says we need more compute power, we need more ability to get signals on and off the panel. We need to develop better sensitivity between the nodes so that maybe we can reduce the node count but still have the touch adjacency or the association that we need. Increased gesturing, increased touch capability. We have true touch capability with some of our controllers. We are incorporating new materials into our panel design to give us better ruggability, more rugged panel, a cheaper panel in looking at how we can reduce cost, reduce volume of material, etc. We work very closely with our customers, handing back and forth 3D models. We work with the customer every step of the way to make sure the panel is a complete integration. The new controller devices that are coming out from Atmel and other controller vendors, you have better noise filtering, you have self-calibration, better processing speeds, better capabilities, which gives better performance, better user experience. We're working with vendors on improved ITO coatings to reduce ITO visibility, as well as other materials to eliminate or replace ITO. New sensor patterns to perform better self-shielding, better noise rejection, and actually better hide the ITO, make it less visible. Optical bonding, there's an example in the foyer out there where it improves clarity, it improves sunlight readability, it makes the unit more rugged, more solid, resilient to shock. High performance specialty glasses and plastics and materials to improve impact resistance and scratch resistance, etc. Projective capacitive touch by far is the growth. It's the market that everybody is adopting. Thank you very much.